Humanoid robots. The dream of a human-like automaton stretches back in human history. Ancient Greeks dreamt up Talos, a bronze giant made by the god Hephaestus. The first emperor of China was buried with an army of terracotta soldiers meant to rise up and protect him in the afterlife. Closer to our time, Leonardo da Vinci built a mechanical knight, one of the first actual attempts to build a humanoid automaton that was meant to be functional. But it was only in the last century when the Czech writer Karel Čapek first uttered the word robot. His theatrical play featuring artificial workers would just be the beginning of a slew of sci-fi stories surrounding humanoid robots.
Thank you for your cooperation. Good night.
Today we look at those early depictions of robots, like the ones from the stories of Isaac Asimov, as a bit naive. Their portrayal of robots was as clumsy as actual robots from the era. We can do better. A lot of companies try to, and the results of their labors is profound. In the last couple decades, robotics progressed further than in the centuries before them. So why is it then that looking forward into the future, humanity's long-lasting dream of humanoid robots might not survive the passage of time?
We seem to be made to suffer. It's our lot in life.
There's a very good reason robots have been a dream for so long. After all, creating one is an extremely difficult process. We often don't think about it when considering humanoid robots, but humans have a pretty complicated shape. The biological intricacy required to keep a human body upright, allow for quick, precise movements, and maintain stability through very different circumstances is truly staggering. Attempting to replicate biological design is called biomimicry, and it's everywhere in robotics. And considering how difficult human shape and motions are to mimic, it presents a unique challenge.
Linear movement or rotational movement of functional robots is very different than a human-like movement, right? The sensors you require for vision, for touch, for balance, you need a more complexity. So you have visual, you have auditory, you have tactile inputs which needs to go in there, and all of them simultaneously. Your humanoid robot has to have multiple subsystems, so motor control, decision-making control, perception control, and if you, on top of all of this, if you have a social interaction requirement, then forget about it, right?
The problem of social interaction can't just be solved with more hardware. It presents lots of other challenges that remain unsolved to this day.
You're not seeing a full body of Arya, but Arya has the shape of a human, which means that the way her arms move and the way she reacts is highly complex. Now, in the robot community, there's two areas that are highly complicated for robots right now. One is walking, and the other one is facial expressions. Where we are far superior than our peers is on the facial expressions, which again is the other highly difficult part of building a robot. And we have built Arya with the ability to make several different types of expressions. I can say, Arya, can we see a smile? There you go, there's a smile. So being able to emote things like smile, show happiness, sadness, tell a joke are far more important for the types of robots that we build.
With dozens of minuscule motors, rotors, sensors, and other tiny elements built into a robot, the brain that connects them all together has to be just as intricate. While the field is brimming with open source software built by various robotics companies, that's also where the problem lies. Each prominent figure in the robotics field designs their own software. You won't find your local Terminator wannabe running on Windows, for example. For any custom hardware, custom firmware is required as well. Now, NVIDIA is spearheading the effort to create standardized software, but only time will tell whether that succeeds. The primary reason there are so many different software solutions is because no two robots are the same. Hardware between them differs greatly, creating the need for custom firmware to pair with it.
Tesla is building one. They want to be able to integrate with Tesla vehicles or energy system or other things they are doing, right? So that tight coupling between the hardware and the software limit that exposure to other companies. And there's also a data lock-in because there's millions of hours spent on training and building this. That performance data helps them improve, so you can't really repurpose it that easily.
And all the technical ingenuity brought into designing a humanoid robot isn't cheap. Billions of dollars are being dumped into various robotics companies, and even more spent on development and research. A single humanoid robot, all of its pieces included, can cost up to $200,000. This kind of price might be affordable for the big names in the game, BMW, Tesla, countless Chinese conglomerates, but what are they spending the money on? What exactly is the purpose of a humanoid robot? Before we get an answer, I want to remind you to please like and subscribe to support the awesome teams behind this video. And let's continue. Cut! This right here is the manufacturing line of a BMW factory. With only a few people in the background, it's a great example of an automated manufacturing line utilizing robots. Not humanoid ones, but a variety of arms, actuators, and other types of robotic implements specifically designed to serve a singular purpose: build cars. And they're good at it. Unlike something like this, which in addition to building cars, has to be optimized to balance itself on two legs, use its fingers, and maybe even show emotions on its face.
If you look at just purely from a quantitative standpoint, whether it's market demand or cost effectiveness or the way adoption rates work within industry, the usability of these things, how better they are at operations, the competitive landscape of the entire, it's just a no-brainer that functional robots are much more viable for industry.
BMW Group's production line runs non-stop, producing 10 cars in any sequence for a grand total of 10,000 cars per day. This means that those machines are in motion, working on their designated tasks 24/7, 365 days a year. A single automated welding gun in the BMW factory can perform up to 15,000 welds a day. And the usage data about the production lines is carefully stored in the cloud, analyzed, and used to predict the maintenance time for each piece of machinery involved in the production. It doesn't take a roboticist to see why the same production line would be problematic for humanoid robots. Humans are poorly designed. Some of our parts are very durable, others not durable enough. While researchers struggled for ages to overcome the design flaws of human bodies, the robots they create are still humanoid. Their joints are constantly under stress. Lifting heavy weights makes them wear down faster. Balancing is a chore too. Robots lack our vestibular apparatus. Each artificial joint and tendon needs to work perfectly to guarantee that their owner won't fall while walking down the stairs. One can only imagine how often this perfectly coordinated system has to be maintained and eventually upgraded, which, considering the complexity of the parts, becomes a problem in itself.
If your sensors are upgraded or your actuators are upgraded or changed, so you have to do recalibration. The recalibration has multiple things. So for example, if your physical attributes have changed, a sensor or a joint which had more flexibility now, then you will have to have addressed your model for motion planning, or your control algorithm would need to retrain to account for this new physical dynamics. There could also be compatibility issues. When you change the hardware, then you break compatibility with the existing AI frameworks, right? So you have to fix that communication protocols. And you have to also think about, of course, safety and stability of your system. So if you might have put a new processor thinking that it's going to work really, really well, but if the calibration is not done, then it may not work well.
Seems like the tape is running out. Like there's just no reason for humanoid robots to exist. Not a single task they can do better or more efficiently than specialized robots. Or wait a second, maybe there's something more to it. For all their downsides, humanoid robots of today are definitely not useless. Rewinding back a bit. Yeah, right there. In reality, while we have automated machines covering a lot of manufacturing, there are still some people working in that environment.
So most of the assembly line things are built in a way that they do one function and they do it really, really well. But if humans are on the assembly lines, they are doing dexterity. They're going under the vehicle and then looking at something specific, or they need to do some intricate assembly. So assembly line is a good use case.
So it seems like there really are niches for humanoid robots in manufacturing. And not only there, humanoid robots have a unique ability to assist or even replace people in dangerous lines of work and emergency cases.
The training and simulation, if you can create realistic training scenarios for human workers in an industrial setting to train the people across oil rig in the ocean, or a drilling happening in a mine, or something which is a dangerous condition, that's a really, really powerful use case.
Now, this is currently only made possible because we've been repeatedly sending those less fortunate to do the life-threatening work. If it's possible to preserve human life and health at the cost of a very expensive and dubiously durable Tin Woodsman, why would we not jump at the opportunity? Though critics can complain all they want about how companies like Tesla and BMW are jumping on the robotic bandwagon just to ride the hype, this train might end up taking them in the correct direction. Besides the clear goal to ride the wave, there's actually another reason why so many companies seem to lean into robotic solutions. Believe it or not, humans grow old, and with them, the overall workforce as well. The aging and decline of the global population is a looming reality that will eventually threaten to cripple businesses dependent on a human workforce. It's not a distant future either. By 2050, the world's population over 60 years old will double, reaching 2 billion people. With that angle in mind, humanoid robots might as well take the place of retiring workers until the working conditions are changed enough to accommodate more specialized machines. And while that's happening, other robots might take care of our slowly aging humanity.
What is the number one thing you'll hear when you go talk to people in retirement homes and elderly homes, right? It's that they don't see their loved ones often enough. It's that they feel ignored, neglected. Is this giving us one more reason to be even worse as human beings, right? Or is it making their life of those retired people a bit more tolerable while they await interaction from their loved ones? I think both are true and can be true at the same time.
And the elderly are not the only people who might get cared for by the metal hands of our future overlords. Japan, for instance, has been using vaguely humanoid robots for medical care for a while now. These assistants can help disabled people interact with the world, care for immobile patients, and provide decent company.
I think with respect to further medical things, our robots can measure a human's temperature from a distance to see if someone has a fever. And so that's sort of the areas that we're looking at, which I would say sort of some of the behaviors that would assist medical practitioners on a day-to-day, especially when there's a shortage of healthcare workers and an abundance of people who are feeling lonely and maybe just want somebody to talk to. You know, let's not forget, loneliness is a costly epidemic. Like, that's depression. That is a whole bunch of things that people don't measure with a hard cost, but it's real. And if we can help to tackle that, that in many ways is as important as, you know, somebody who comes in and gives you an injection or does an operation.
Being cared for by a robot might sound weird, but robotic animals have performed well as therapy tools for young and old alike. Think of it, a shiny, smooth pet that doesn't poop, make a mess, or cause allergies. Maybe I should get one. I'm only kidding, Jojo. So there are certainly some applications for humanoid robots. Very important ones, too. Anything that can benefit human life and health is an endeavor worth pursuing. But is that really it? Does humanity's millennia-long dream of an automated workforce, faithful companions, stalwart vanguards really only amount to this much? Our dreams for humanoid robots have always been greater than that. We've aimed to send them to space alongside astronauts to conquer the stars, but we've settled for more efficient rovers and copters instead. We've wanted an unbreakable army of glorified Terminators, but it turns out that an unmanned drone holding a bomb is much more effective. We've wanted housekeepers and cleaners, but I dare any humanoid robot to try outpacing a Roomba. Perhaps we've dreamt a bit too long, and by the time we grew up enough to realize this ancient dream, it turned out that the result was not as great as we expected. Humanoid robots were a grand dream. A dream long dreamt, long pursued. A dream beloved by kids and adults alike. A dream that nurtured generations of skilled engineers, programmers, and enthusiasts infatuated by it. Maybe, just maybe, we should have kept dreaming. Thank you so much for watching. This video was brought to you by an entire team of people here at Cybernews, and they would love to know if you enjoyed it. So don't hesitate to leave a like, a comment, or maybe even press that subscribe button. It'd mean a lot to us. Until we see you in the next video, bye.